This is SpaceTime, Series 29, Episode 78, for broadcast on the 1st of July 2026. Coming up on SpaceTime, discovering how the cosmic dark ages ended, new clues about the origins of interstellar comet 3I Atlas, and the pink planet with a salty surprise. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered an early galaxy dating back to the era of Reionization, when the universe was transformed from the cosmic dark ages, when the cosmos went from being opaque to becoming transparent, like it is today. The galaxy, catalogued as MXDFZ 4.4, existed some 1.4 billion years after the Big Bang. Observations by the Hubble Space Telescope show ultraviolet light from tightly clustered young stars in this galaxy are ionizing the opaque neutral hydrogen gas within and immediately around the galaxy, clearing our view. The findings, reported in the Astrophysical Journal, suggest that similar galaxies in the early universe were also responsible for clearing the neutral fog of hydrogen gas that once filled the cosmos. The galaxy existed at the end of the era of reionization, a transformative period in the universe. During roughly the first billion or so years of the cosmos, the gas between stars and galaxies was opaque, but as more and more stars began to shine, generating ultraviolet energy, the gas everywhere was ionized and became transparent. Now, this changeover wasn't like an on-off switch. Astronomers are still collecting evidence to fully understand how it happened, which is why this discovery is so important. The study's lead author, Elias Gavaritz, from the Space Telescope Science Institute in Baltimore, Maryland, says observing a galaxy like this was thought to be impossible. Researchers expected the fog of neutral hydrogen that filled the early universe would simply be too thick, obscuring our view of its ionizing light. But Hubble not only spotted that light, it also helped reveal incredible details about the galaxy's characteristics. Young massive stars emit loads of ultraviolet light capable of ionizing hydrogen atoms. As this light travelled for more than 12 billion years to reach the Hubble Space Telescope, space-time itself expanded, and the light waves themselves were stretched or redshifted from the ultraviolet into visible wavelengths. Hubble's wavelength coverage, combined with the sensitivity and resolution of its space vantage point, makes it the only telescope capable of capturing this ultraviolet light from the early universe. Astronomers have found many galaxies that existed at this point of history in the early universe, but they haven't detected ionizing photons from any of them, making this discovery a one of its kind. Hubble revealed that the young galaxy's massive stars were the source of the ultraviolet light which cleared the surrounding space. These stars formed in bursts within the last few million years of MXDFZ 4.4's existence, and they're all crammed together. Amplifying this crowding effect, the galaxy itself is about 100 times smaller by area than, for example, our own Milky Way galaxy, but it's forming stars 10 times faster. Gavaritz says that a lot of young stars, hot massive stars in a small space, do a better job of blasting through opaque gas. And the massive stars' lifetimes also play a role, since they live at most for only a few million years, burning through their fuel supply much quicker than smaller stars like our Sun. Many of these big stars exploded as supernovae, in the process releasing gigantic amounts of energy and blowing colossal holes that allow even more light to escape. Following their Hubble discovery, the authors used the Webb Space Telescope to determine the galaxy's mass, analyze its older stars, and measure the galaxy's star-forming history. They found the galaxy's older stars are less massive and cooler, and therefore not responsible for changing the gas around them. Comparing Hubble and Webb data also showed that the recent star formation happened in bursts. Meanwhile, data from the ground-based Very Large Telescope in Chile pinpointed exactly when MXDFZ 4.4 existed 1.4 billion years after the Big Bang. Before this discovery, researchers had identified only one galaxy emitting ionizing light from this time period. That was when the universe was 1.6 billion years old. Only a few additional examples have been identified, and all those existed when the universe was already around 2 billion years old. MXDFZ 4.4 brings astronomers closer to drawing firm conclusions about how the era of reionization unfolded. Back in 2023, astronomers using Webb showed that galaxy stars emitted enough light to heat and ionize gas around them 900 million years after the Big Bang. That was a breakthrough, but astronomers needed galaxies like MXDFZ 4.4 to fully explain how the process actually happened. That's because it shows how the high-energy light from young stars managed to escape the gas and dust within the galaxy itself. This report from NASA TV.
Astronomers using NASA's Hubble Space Telescope have observed ultraviolet light escaping from a galaxy that has existed since only 1.4 billion years after the Big Bang. The galaxy, called MXDFZ 4.4, appears during a critical period known as the era of reionization, when the universe transformed from a dense cosmic fog into the clear cosmos we see today. Hubble revealed tightly packed clusters of young, massive stars blasting energetic radiation into space, carving holes through thick clouds of hydrogen gas. Researchers estimate that as much as 50 to 100% of this ionizing light escaped the galaxy. Despite being about 100 times smaller than the Milky Way, MXDFZ 4.4 is forming stars 10 times faster. Hubble's visible light observations were combined with infrared data from NASA's James Webb Space Telescope and observations from the European Southern Observatory's Very Large Telescope. This finding implies that similar galaxies in the distant, early universe were responsible for clearing the neutral fog of hydrogen gas that once filled the cosmos.
This is SpaceTime. Still to come, new clues about the origins of interstellar comet 3I Atlas, and a pink planet with a salty surprise. All that and more still to come on SpaceTime. Astronomers using NASA's Webb Space Telescope have discovered new clues about the origins of interstellar comet 3I Atlas. As it began moving away from the Sun back in December 2025, astronomers captured detailed measurements of its chemical components. The comet was freshly warmed by its close encounter with the Sun, allowing its ancient ices to sublimate and degas into space, in the process forming a bright coma around the nucleus, ideal for study. Webb captured detailed data, including chemical ratios of carbon and deuterium and isotope of hydrogen. The results, reported in the journal Nature, surprised astronomers. Working backwards, the authors used the components that make up the comet to understand the environment in which it formed. The study's lead author, Martin Cordner, from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says it was a unique opportunity to study an ancient object from the distant parts of the galaxy, probably predating the existence of our Sun and solar system. Cordner and colleagues found exceptionally high levels of deuterium, about 30 times more than what's seen in solar system comets. Now this implies that 3I Atlas must have originated in a very cold star system much earlier in the history of our galaxy. During its formation, the material that became incorporated into 3I Atlas was likely exposed to plenty of radiation, but not any long-term warmth that would have reprocessed its heavier water ice filled with deuterium into the type of H2O ice we're familiar with here on Earth. Additionally, Webb showed only traces of carbon-13 compared to lighter-weight carbon-12. And that also points to a very old origin, as stellar systems become enriched with carbon-13 over time as generations of stars are born and die in the galaxy. That's why there are higher levels of carbon-13 in our system around the Sun, which formed relatively recently, some 4.6 billion years ago. In fact, the authors are now estimating 3I Atlas could have formed as long as 10 to 12 billion years ago, during the so-called universe cosmic noon, when star formation was at its height. Its young origin system was likely ensconced in a relatively cold, dense cloud. And the abundance of heavy water shows that 3I Atlas spent its formative years in a deeply frozen state. This is SpaceTime. Still to come, a pink planet with a salty surprise, and later in the science report, claims that the great apes, including humans, have been laughing for at least 15 million years. All that and more still to come on SpaceTime. Astronomers have discovered exotic salt clouds unlike anything ever seen before, surrounding a distant pink planet considered one of the coldest objects ever studied. The findings, reported in the Astronomical Journal, provide some of the first direct evidence of salt clouds in a cold object's atmosphere. The pink planet, catalogued as GJ504b, orbits a Sun-like star 57 light-years away. Despite its description, astronomers really aren't sure if it's a planet. It's roughly 25 times the mass of Jupiter, meaning it sits in the sort of hazy boundary area between the largest planets and the smallest failed stars known as brown dwarfs. To be safe, astronomers often refer to these things as planetary mass objects, meaning that it's a planet-sized object orbiting a star. It was first discovered back in 2013. The study's lead author, Anish Baburja from Northwestern University, says the pink planet appeared to be the coldest planet-sized object ever discovered using ground-based telescopes. While most directly imaged exoplanets are around 500 to 1,000 degrees Celsius, this hazy rose-coloured world was only around 290 degrees Celsius. The authors say its chilly temperature is due to its age. They say giant planets are born blisteringly hot, but cool as they age. And based on their estimates, GJ504b is somewhere between 2.5 and 4 billion years old. That makes it a lot younger than the Earth. Many astronomers around the world performed follow-up observations to study the planet's light, but it was simply too faint for ground-based telescopes. But that made it a perfect target for NASA's Webb Space Telescope. The authors say when they finally obtained its spectrum, it immediately looked interesting. And once they started digging deeper into the data, they realized it was like nothing ever analyzed before. Different patterns of elemental lines in a spectrum's rainbow reveals details about its chemical composition. And the data for the pink planet revealed a rich mix of chemicals, including water vapor, methane, carbon dioxide, ammonia, and other molecules. But something didn't add up. The data only matched the observations if it contained unusual, physically implausible features. So the authors added clouds of different chemical compositions to their models to see if they could make these unusual characteristics vanish. They found that salt clouds likely veiled the planet's deeper layers, shaping the light that reached Webb. The spectra also suggested that GJ504b is unusually rich in heavy elements or metals. Astronomers refer to all elements other than hydrogen and helium as metals. However, the mystery of this object's formation still persists. Current data suggest it could have formed either as a planet or as a small star. Only further, more detailed observations will provide an answer. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that Wegovy, one of the Ozempic-like GLP-1 agonists for weight loss and diabetes, may carry the highest risk of eye stroke and sudden loss of sight compared to other semaglutide drugs. The findings, reported in the British Journal of Ophthalmology, looked at unintended side effects of the semaglutide drugs and found that the risk of ischemic optical neuropathy or eye stroke caused by inadequate blood flow to the eye and resulting sudden vision loss is rare. But among the rare cases, it's almost 5 times higher with Wegovy compared to Ozempic and 3 times greater in men than women. A new study has identified a biological signature within kidneys that could help predict age-related organ failure. A report in the journal Cardiovascular Research shows that the shortening of the telomerase within the kidney cells may contribute to the development of nephrosclerosis, a major contributor to chronic kidney disease. Largely irreversible and asymptomatic until it reaches an advanced stage, chronic kidney disease is often called a silent killer. By identifying the specific pattern linked to kidney damage, the findings could allow doctors to identify high-risk patients early. A new study claims that the great apes, including humans, have been laughing for almost 15 million years. The findings, reported in the journal Communications Biology, analysed recordings of 140 sequences of laughter from 4 orangutans, 2 gorillas, 3 bonobos, 4 chimpanzees, and 4 humans, aged between 6 months and 7 years. They found that laughter seemed to follow regular rhythmic patterns, with evenly spaced intervals between successive sounds. And because this same pattern was present across all the species studied, the authors say it was probably already present in some commonly shared ancestor some 15 million years ago. A decade-long study has found that young people who spend 2 hours or more a day on social media are far more likely to experience depressive symptoms and poorer well-being than those who limit their use online to an hour or less. The research, reported in the Medical Journal of Australia, involved 1,200 kids from Melbourne. They found the strongest impact on mental health was among girls aged 12 and 13, although small but noticeable increases in mental problems were seen in both genders between the ages of 12 and 18. Although this increased risk is small, the study's authors say it could affect significant numbers of people at a population level, and so follow-up study is essential. Well, it's now been 6 months since Australia's social media ban for under 16-year-olds came into effect, and new studies have found that 85% of kids are still able to access child-restricted sites online. In December last year, the Australian government became the first nation on earth to ban social media for children under 16, prohibiting them from having accounts with many social media platforms, including TikTok, X, Facebook, Instagram, YouTube, and Snapchat. Interestingly, however, Australia's left-wing Labor government continued to allow children to access socialist platforms like Blue Sky, which are often echo chambers for far-left conspiracy theorists. Britain's own proposed social media ban for under 16s will come into force next year, blocking kids' access to Snapchat, TikTok, YouTube, Instagram, X and Facebook, and from live streaming or communicating with strangers on gaming sites such as Roblox. Now, a new study by the University of Newcastle, looking at online activities of more than 400 Australian teens aged 12 to 17, found only limited compliance with the social media minimum age legislation and little reduction in social media usage by kids. The kids are easily getting around it. Some of the problems the software itself. Kids often pass age checks using their own accounts. But if that does fail, they usually resort to fake accounts, their parents' IDs, fake facial ID scans, or by using VPNs or browsers like Tor and Brave. While everyone wants to save the children, the main community concerns about the social media restrictions centre around requirements to provide digital ID to access accounts. That's because this allows governments, politicians and bureaucrats to build up detailed data sets on your digital information and history, monitoring your digital footprint, including the sites you visit, the images you look at, and for how long you're looking, to see the stuff you're posting online and where, tracing where you travel, even accessing your medical, employment, banking and taxation records, as well as any traffic violations, criminal or misdemeanor history you may have. It also provides a one-stop shop for hackers to access your personal information. And multiple previous experiences have shown us all how easy and often that happens. China's communist government uses digital ID as a big brother, tracking people's movements using facial ID and enforcing its universal social credit scheme, which rewards you for correct thinking and punishes those who question government policy. The social credit scheme dictates where you can live, where you can work, where you can travel to, and even the types of healthcare you get and the schools your kids can attend. And it's not just Beijing. Canada used digital ID to first identify and then freeze the bank accounts of protesting truck drivers. And when the Australian government forced citizens to get special COVID digital IDs, police used them to track people's movements, despite government assurances that couldn't happen. Technology editor Alex Zaharov-Reutt from TechAdvice.life says digital ID is the golden treasure chest authorities dream of.
Yeah, reports say that plenty of kids are still on social media. They can use a photo of somebody else or use some AI to make themselves look older and then hold a photo up from one phone to another phone. I mean, this is all sort of ham-fisted. The protection of the children isn't the real concern here. The real concern from the government is to identify everybody on the internet and force them through, false claims of protecting the children to identify themselves and then be trackable. So we have to be really careful to allow governments to do this and erode our freedoms. The kids find a way around. They use VPNs. They use services like Blue Sky, which in Australia are not part of the under 16 social media age ban. So there's a lot of inconsistency. You don't want your kids there. If you think X is bad, then some of these other ones are worse. So there's this hypocrisy. The government tries to do one thing and the kids find a way around it. And this ban has been an abject failure. Now there is calls from some in the industry and the community to clamp down, make this a stronger ban, but that's only going to fuel people to continue finding ways around it. And personally, I'm just not impressed. I'm not a fan of these bans.
That's Alex Zaharov-Reutt from TechAdvice.life, and this is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.